We can start with this exercise on, you have perfect competition, and then we have taxes. So here we have 4 identical firms. So we have n equals 4. And then we have the short run cost function. So usually we're going to need the marginal cost and the average cost. Notice how they do give you the marginal cost in question 1, but they don't always do that. So they expect you to be able to do that yourself. So if we want to find a supply curve, we need to figure out how much we're going to produce for the different prices. So first you have to find the shutdown rule. You have to check if the shutdown rule is always satisfied. So the idea is that you're only going to produce if the price is greater or equal to the minimum average cost. And in order to find the minimum average cost graphically, it generally, the graphs for the costs look something like this. You have average cost, which is like that, and marginal cost, which usually is something like this. The point is that the minimum of the average cost always coincides with where marginal cost crosses it. So that's generally the best way to find it. So basically, we first set MC equal to AC to find the minimum price that we would ever produce for. And then after that, we can find a supply function. So they tell us the marginal cost is 2y. Either way, anything that's marginal is always just a derivative of the total one. So whether we're talking about like revenue or cost, is always like that. So even if they didn't give it to you, we would just derive that, and then we would get 2y. And then for the average cost, you're just taking the total divided by the quantity. So we have total cost over y. Total cost was y squared. And so over y, that's just going to give us y. So we make them equal to each other. And you could just bring the y's to one side. You're just going to end up with y equals 0. So sometimes it's 0, sometimes it's not. It usually depends on whether we have a fixed cost or not, which in this case, we actually don't, because you can see that you don't have a fixed number added on to this. Otherwise, that would be the fixed cost. And remember that we need to find the minimum average cost. So not just the quantity, but the min cost associated to that. So we just have to plug in y back into either this or this. It doesn't matter. So you can just pick whichever one is easier. And that's just going to give us 0. So it's a bit of a particular situation, because basically we're saying that the minimum average cost is 0, so we would produce for any price greater than 0, which essentially just means any price. Usually that's not the case, so usually we would get something like, I don't know, 10 or something, and then we would say that we only produce if the price is greater or equal to 10. So then you have to consider that obviously every firm wants to maximize its profit, so now we need the profit maximizing rule, which is the same regardless of the type of firm that you are dealing with. So like for perfect competition or monopolies, it's the same. We have to take the marginal revenue equal to the marginal cost. And marginal revenue, if we know that we're dealing with perfect competition because they tell us that we have a competitive market, then the marginal revenue is just going to be the same thing as the price. So MR is equal to P for perfect competition. And the marginal cost we found before, it was 2y. So we have P equals 2y. So this is just from over here. And because we're trying to find a supply function, we want to solve for y. So if we solve for y, we're going to end up with P over 2. So as I was saying before, usually this is not 0. So then you would have a supply function that's piecewise defined. Like you would have, like, for prices less than something, you have that you don't produce because you shut down. And then for prices greater than something, you have this supply function. In this case, obviously the price is positive, so we don't have to bother specifying the first part. So this is just simply our supply function. So I think that's all they wanted for the first question. Yeah. Oh, they also want the market supply curve. So this is the individual firm. The market just has 4 firms that are identical. So they're just going to produce that quantity times 4. So we can use capital Y for that. And also we can put an S just to specify that it's supply, not demand. So we just take 4 times that, and that's going to simplify to 2p. So market is always very easy. And of course, if you wanted to go in reverse, you would just divide by 4 to get the individual firms. So now we want to find the competitive equilibrium. So we're talking about the market. So we just need the market demand and the market supply. They gave us the market demand, and we already had the market supply from before. So we can just make them equal to each other. So we found 2p for supply, and demand, they have to give that to you. So that's 21 minus p. And then we end up getting 3p equals 21, so p equals 7. And then by plugging it back into either the supply or the demand, doesn't matter, because we're at equilibrium, we can get the quantity. So I'm going to plug it into that one, but doesn't matter. You got 2 times 7, so 14. So this is the market demand. I don't think, sorry, not the market demand, the market quantity, I meant to say. And I don't think they ask us, but if they asked us for the individual firm quantity, then we would just take that and divide by 4, because we had 4 firms. In this case, that would give you a decimal. So obviously it's a bit of a weird situation, but you would just leave it like that. So they want us to represent it on a graph. So for the graph, we're going to put the quantity on the x-axis, so that's y, and then the price on the y. And so to graph it properly, you'd have to actually find the inverse supply and the inverse demand functions, because you need to solve for p in order to be able to graph it somewhat accurately. So we had that supply was equal to 2p. I'm just copying this from over here. So if we solve for p, we get y over 2. So that's just like saying a half y. So that's just a straight line. That's not very steep. So something like this. And then for demand, we have demand equals 21 minus p. And again, we solve for p, and we get 21 minus y. So that's a straight line with a slope of -1 and an intercept of 21. So something like that. And so then our equilibrium was 14 for the quantity, and then 7 for the price. So I think they also wanted to know the surpluses. Yeah, so producer and consumer surplus. So that's always pretty easy to understand from the graph, because with producer surplus, you know that basically producers were willing to sell at these prices on the supply function, and what they actually sold at was 7. So essentially, this is extra money that they got on top of what they were willing to sell for. So that's basically their surplus. So it's just a difference between the graphs of the price and the supply function. And then for the consumers, it's the opposite. Basically, consumers are willing to spend they're willing to pay these prices for these quantities here. And then what they actually paid was 7 for each unit. So that's basically a discount that the consumers received. So that's going to be your consumer surplus. So we also have to compute them. So if you want to compute them, it's just going to be the area of a triangle. So for the consumer surplus, we know that the length of the triangle is 14. The height is the difference between 21 and 7, and it's a triangle, so we have to do a half times the base times the height. So a half times 14 times 21 minus 7. So that should end up being, let's see, 14 times 14 over 2 should end up being 49. Oh, sorry, 98. And then for the producer surplus, we take the blue triangle. So again, a half times base times the height. The base is still the same as the quantity. And the height is now 7 minus 0, because it's just this. So now we take a half times 14 times 7, so that's going to be 49. And so if you add those together, you're just going to get your total welfare. So 98 plus 49. Okay, now we have a tax. Remember, with taxes, they're usually on the producers, but they could also be on the consumers, so they have to specify. So obviously, if it's on the producers, it's going to affect supply, and if it's on the consumers, it affects the demand. And make sure that if you have like a question where you're looking at the graph, you realize that you have quantity here and price here. So if this is your demand function, if you have a tax, that's going to affect the demand in the sense that it's going to shift to the left. So, oops, sorry, wait. Yeah, so for each price, we're going to have a, let me just check that. Wait 1 sec, why am I getting confused here? No, sorry, that's going to shift to the, should be actually to the right at least. Yeah, because basically prices go up. I'm sorry, wait, let me just check that in my notes. No, yeah, that was right in the first case. It was going to shift to the left. So, for example, if this was the original equilibrium, then if you're going to have a tax, it's going to become this one. So you're going to purchase less. So you just have to think about the quantity. If it's going to go down or go up, obviously with a tax, quantity goes down. And then with a subsidy, it would be the opposite. So it's going to move to the left. So make sure you think about it that way when you're looking at the graph. So now for question 3, we have the specific tax on each unit produced. So that's on producers. And they tell you that the tax is 3. So they even tell you how it changes, but also intuitively, it just means that for each unit, they're going to spend €3 more. So that's affecting the marginal cost and also the total cost. But specifically, the marginal cost is what we care about, because if you want to find the new equilibrium, we need to go through the same procedure as before. So basically, we have that marginal cost changes, and also actually average cost changes as well. So we would have to find the new supply function, and then the demand function stays the same. So if you wanted to find the new equilibrium, you would just have to set them equal to each other like before. So basically, we have MC with the tax, so we can just call the MC T. And that's going to be, as they told us, the old one was 2y, so we add the tax of 3. So if we do the average cost, again, it was total cost over quantity. But now with total cost, previously it was y squared. Now we also have to pay a tax per unit. So if the tax is 3, the total cost that you're going to pay extra is 3 times y. And then we're dividing that by the quantity. So that's going to simplify to y plus 3. So just like before, we need to apply the shutdown rule. So we make marginal cost equal to average cost. I'm just going to put a T to indicate that this is with the tax. And if you simplify, you still get that y is going to be 0. So same as before. But now, if you find your min average cost, which we can get again by plugging it either into this one or this one, now you're going to get something different than before because you have the tax. So specifically, that's going to be 2 times 0 plus 3, so 3, which is just the tax. So it's kind of logical if you previously had a min average cost of 0 and you now have a tax per unit, it's simply going to go up by the amount of the tax. So now the minimum price that we can accept is going to be 3. So we would shut down if the price is lower than 3. So just like before, we then have the profit maximizing rule that we have to use to find the supply function. So that's again MR equals MC, and again it's perfect competition, so the margin revenue is the same as the price. And marginal cost is now this one, 2y plus 3. And because we want the supply function, we want to solve for y. So we're going to get 2y equals p minus 3. And so y equals p minus 3 over 2. So this is assuming that we don't shut down. So this is assuming that the price is as we said before, now greater or equal to 3. So the supply is going to be nothing if price is less than 3. And if it is greater or equal to 3, then we're going to produce this much. So I think that's all they wanted for that. Yeah, they just wanted the new market supply curve. Oh, actually, yeah, so we need to, that was an individual supply curve. And so for the market supply, we had 4 firms, so we have to do 4 times little y. So we multiply both these two by 4. So that's still going to be 0 here, and then that's going to be 2 times p minus 3. So now they want to know in 4 how many units, so the new quantity, the new equilibrium, and then the 2 prices. So in this case, we already have the new supply function and the demand curve that hasn't changed, so we can just make them equal to each other. So we had y supply, and I'm just going to put again the T for the tax. Demand was not affected. So if price was bigger, I think we said than 3. Yeah, bigger or equal to 3. We had a supply function, which was 2 times p minus 3. So I'm just copying this portion. And then we're going to make it equal to the demand function, which hasn't changed. And the demand function was, I think, 21 minus p. So that's going to give us 2p minus 6 equals 21 minus p. So if we simplify, that's going to give us 3p equals 27. So P equals 9. So this will be the price that the consumers pay, because it's on the original demand function. So that's how you know that it's specifically the one that is paid by the consumers. If instead it had been the opposite way around, so if the tax had been on the consumers, then what we would have found would be the price that the suppliers receive. So afterwards, I'll mention like another way that we could have done this, just so that you don't risk mixing up which one is which. But logically now we know that if the consumers are paying 9, the producers are paying a tax on what they receive of 3 euros. So what the producers actually receive in the end is going to be 3 less than that. So we're going to take the price minus 3, and that's going to give us 6. You can also think about it with the graph. That basically what we found was we changed the supply function. So basically the idea is that the supply function shifted, specifically it shifted left. And it's better to think of it as left or right versus up or down, because this way it's consistent with demand. So generally, if there's a tax, whether it's on supply or demand, supply or demand is going to go down, so it's going to shift left. And so the point is that what we just found was this one. So if you see where this point is, you can see that it's on the original demand curve, not on the original supply curve, because it's on like the new supply curve. So the point is it's still what the consumers pay. And what the producers actually receive is going to be the price that you have down here on the supply function. So basically you always have to find the prices on the original supply and demand, which means that in this case you would have to shift down by the amount of the tax, which was 3. So I think that's all they wanted. Yeah, they just wanted the prices. And what I was just going to recommend before, just so that you don't necessarily have to look at the graph, is rather than doing it like this, by setting the quantities, the supply and demand equal to each other, you could also think of it as, we know in general that there's going to be a difference of the tax between the two prices. So we know like that the price of suppliers that suppliers receive is going to be the one that consumers pay minus the tax. And keep in mind that if you had the opposite, that the tax was on the consumers, then basically we would be saying that consumers pay a certain price plus the tax. Either way, it's the same thing, because you're just moving the t to the other side of the tax. And so my point is that if you do it like this, then you can replace PS with the inverse supply function and PD with the inverse demand function. And that's pretty easy to find, because you just take these ones and solve for P. The reason I think that's better is because by doing that, you're going to solve toward the quantity. And then you can easily plug the quantity back in to find the two prices. Just because I think otherwise it's a bit, it can get a little bit confusing in terms of like whether this is the price that consumers pay or is the price that suppliers receive. And it's two different things. So then you have to know whether you should add the tax or subtract the tax. And I think by doing it that way, it's going to be easier. So maybe afterwards, I'll also send you like the notes of like how I would have done it that way. But here you can also kind of understand it graphically. The point is that you have to find, you know that you found this price, and so the only other price you have to find is this one. So logically, you see that you have to go down, so clearly you have to subtract the tax. So also just to look at it graphically, we can copy this graph. They didn't ask us about the deadweight loss, but since they do ask it often, we can just see how you would calculate it. So we had supply changed, and it shifted by 3. So something like that. And so the new equilibrium was this point. So we found out the price was 9, and here it was 6. So this is price consumers pay, and this is what producers receive. So you can see that in the end, the tax, the burden of the tax is on both the consumers and the producers, because the consumers are paying 2 more and the producers are getting 1 less. So how much each of the 2 is affected by the tax depends on their elasticity. So they also wanted the new quantity, so that's pretty easy. We can just plug in the price into the demand function or the supply function. So if we're going to look at it from the demand side, we have to put in 9 into the demand. Demand was 21 minus the price, so 21 minus 9, so that's going to give us 12. Or you could have plugged in the price that the suppliers receive into the supply function. It doesn't matter, but just be careful to not mix it up. And anyway, the deadweight loss, we can find that by getting the triangle that's going to be in between basically these lines over here. So we could just calculate that again by doing 1/2 times the length times the height. Generally, we're going to see also with subsidies and, sorry, not subsidies, I meant to say externalities, but actually also subsidies, that with all of these things where basically you have a shift and there is a deadweight loss, just to kind of make sure that you don't take the wrong triangle, because sometimes they can get a little confusing. You want to think of it as you need to take the 2 equilibriums that you found, which are these 2. And then you want to take the original supply and demand, which is this and this. So basically ignore the purple line. And you want to draw the triangle created by these lines and those 2 points. So then you can see that you have to extend this over here. So later we'll also use that same logic for externalities. I think sometimes with externalities, it's a bit confusing because sometimes you have a triangle like to the right and sometimes to the left, depending on whether it's a positive or negative. So if you just always do it that same exact way, then you really can't go wrong. So if we want to calculate the deadweight loss, it's a triangle. So we have 1/2 times the length, which is 14 minus 2. And the height, which is the difference, which is also just the tax. So it's 1/2 times, so this is 12, 1/2 times 2 times the tax of 3. And so we end up with 3. So this is a difference in total welfare, specifically the loss in total welfare, compared to the original situation where we didn't have the tax. Okay, so if anyone has any questions, feel free to tell me now before we go on. Okay, so now we have the other 2 exercises on externalities. So with externalities, you have 2 main types of exercises. You have the first type, which is where you have 2 specific firms, and one has a positive or negative externality on the other one. And then you have the other case where you have the externality on society in general. So like with vaccines or with like firms that cause pollution to society. So it's just 2 different types of exercises. So here we have 2 firms producing perfect substitutes. And they're priced the same way. And then we have the 2 cost functions. So right away, what you want to notice is that the cost function of firm X or firm A only depends on its own quantity, which is X, while the cost function for firm B depends on its quantity Y, but also on the quantity of the other good. So that's how you know that there is some type of externality. So if we focus on firm B, you can see that as quantity of X goes up, there's a minus here. So that means that their cost is going to go down. And so if that happens, that means that X has a positive externality or A has a positive externality on B, because as A produces more, firm B is going to have a lower and lower cost. So basically B is taking advantage, or can take advantage of the fact that the A causes its cost to go down. So basically as firm A produces more, so X goes up, cost of B goes down, so A has a positive externality on B. So make sure you don't get confused by the fact that there's a minus sign. I think people sometimes associate that with negative externality, but if you think about it, it's making the cost go down. So obviously that's a positive effect on B, not a negative effect. And of course, if it had been a plus, then that would mean that as A produces more, the cost of B goes up. So that means that A has a negative externality on B. So the main concept is just that basically B is getting an advantage from firm A that it's not basically compensating firm A for. So the idea is that if the government wanted to intervene, they would probably give a subsidy to firm A, because the idea is that firm A should kind of be compensated for the positive externality that is causing. Or they could try to kind of force B to pay for the positive externality that the A is kind of giving it. Or the other option, if the government doesn't intervene, firm A could, since firm A is the one that basically isn't being compensated, they might want to convince firm B to merge. And by merging, then the externality would be eliminated. So yeah, it's gonna depend on what they tell us to do here. So first we have that they're acting independently. So it's just basically two separate firms acting completely separately. And neither of them internalizes the external effects. But that's really implied if they're acting independently. So if they're acting independently and we're dealing with a competitive equilibrium, then we have to do the usual thing of finding the profit maximizing quantity. So we can take MR equal to MC, first for firm A and then for firm B. They are price takers because their prices are both, they're already priced at 20 regardless of the quantity. So both marginal revenues are 20. And the marginal costs, we have to find them. They don't give them to us, so we have to derive the cost functions to find them. So if we're looking at firm A, remember that firm A has, its quantity is X, so we're gonna derive with respect to X. And if you derive X squared plus 10, that's gonna give you 2X. For the other firm B is producing Y, so its marginal cost only depends on its own production, meaning that we're going to derive with respect to Y, so it's a partial derivative. So you're always deriving with respect to like the firm's own quantity. And that means that the 4X is going to be treated as a constant if we're deriving with respect to Y. And so we're going to end up with just 4Y. So basically the idea is that because firm B can't have an effect, can't directly cause A to produce more or less, its marginal cost doesn't depend on that, because this is just taken as like an unknown constant. So now we can just copy those. We have 2X here and then 4Y here, and then we can get the two quantities. So we get X equals 10 and then Y equals 5. So they wanted the sales, and now we want to find also the profit. So usually we just want to calculate profit by taking total revenue minus total cost. So we need total revenue of A and total cost of A. For total revenue, we can just take the price times the quantity. So price was 20 and quantity was 10. And total cost, we can just plug in the quantity into the cost function that they gave us. And let me just check what that's going to give us. Okay, that's going to be 90. And then for B, we take revenue of B minus cost of B. So price was still 20, quantity is 5. And then the cost function was this. So we have to plug in both X and Y. And that's going to give us also 90 in this case, but that's just a coincidence. They're not always going to be the same because that really depends on their cost functions. And in this case, the cost functions were actually pretty different because this was X squared here and that was 2Y squared, but then this had a plus 10. The point is that they're pretty different, so it just depends. So basically the idea is that if we forced the firms to internalize the externality, basically that would mean that we essentially remove the externality. And so the idea is that firm B was benefiting because remember that it decreased the total cost. Specifically here, you can see that it decreased the total cost by an amount of 40 euros here. Because this portion of the cost function which depended on X was 4 times X. So in a perfect situation, basically firm A would get those 4 euros back in a sense that firm B would now take away 4 euros from their profit and give it to firm A. And this way they would be kind of compensated for the externality. But obviously we don't do that unless they ask us to do that. So now we want to know if the sales are going to be greater, lower, equal to the socially efficient. So if the firms are run jointly, that's saying that they're merging. So that's what I was mentioning earlier. If you're going to merge them so they become one single firm, essentially no one has an externality anymore. Everything is being internalized. So the idea is that in general, anytime you remove the externalities, overall society is going to be better off. So that means that overall there's going to be a higher production than there was before. So first we can already answer that. So we can say that the sales that we have at the moment, so the 10 and 5 put together, so the total sales of 15, that's going to be lower than the socially efficient. So socially efficient sales, which is X and Y put together, will be higher. And that's because of the removal of the externality, which also means that we're removing the deadweight loss that there was before. So X plus Y is going to be higher. So for society, that's better. Now for the individual firms, they want to know also if this new equilibrium, which is going to be the social efficient sales, if that's going to be a Pareto improvement. So Pareto improvement means that both firms individually are either equally, well, one of them is better off and the other one is not worse off. So specifically, that means that no one is worse off and at least one of them is better off. So to do that, to figure out if the firms are better off, they don't really care about the actual sales. What they care about is the profit. So we'd have to figure out if the profit is different. Now, the question here doesn't make much sense because it's a bit of a weird question in a sense that before we were talking about the firms individually and now we're talking about them jointly. So it doesn't really make sense to kind of separate the profits anymore since they're being run together. But if we do that anyway, we're going to see what happens and then we'll compare the profits before and after. So we have to find the social efficient sales. And so that's when you have the merger. So if you have the merger, so it's basically just one big firm producing everything, then the total cost function is just the sum of the two individual cost functions. So we had the total cost function for x, which was x squared plus 10. For y, it was 2y squared minus 4x. We're just going to add them together. So the other one was 2y squared minus 4x. And then we're going to proceed the same way to find the profit maximizing quantities for each of the two goods. So as usual, we have to take MR equals MC. And again, MR was just equal to the price because both goods were priced at 10 or 20, sorry. And then we have to find the two marginal costs. So 1 second, I'm just having an issue with my pen. Okay. So just like before, we have to derive to get the marginal costs. First with respect to x, so that means we're going to have 2x. This becomes 0. We're deriving with respect to x, so this also becomes 0. And this becomes minus 4. And then for firm B, we derive with respect to y. So this is all constant, so that becomes 0. This becomes 4y. And this is also constant, so it becomes 0. So notice actually how if you look at the marginal costs, for B, nothing changed. Because for B, we had marginal cost here, which was 4y, and it's still 4y. But now because firm A is internalizing the externality, so essentially it's not an externality anymore, the marginal cost of A changes. Specifically, it's going to go down because it was 2x, and now it's 2x minus 4. So basically, it's almost as if now A is being compensated for the externality that it was causing. And so it's going to kind of benefit from that. So that's why it's basically now a better situation for A in a sense, and a worse situation for B. And then we proceed the usual way. So we take MR equal to MC. So we have the marginal revenue for both was 20. And then we solve for x and for y. So here we got 2x equals 24, so x equals 12. And then for B, nothing should change because the marginal cost didn't change. And so we still have y equals 5. So the overall quantity only goes up for x and not for y. And that's again because basically A is now benefiting from the positive effect that it was previously causing B. So the quantity goes up here, but not here. It stays the same. So overall, society is better off because quantity goes up. But now to see if the firms are better off, we have to look at the profit because obviously they care about the profit. So intuitively, we could say that for firm X, it's better because they are their cost function essentially improved in the sense that now they're benefiting from what was previously an externality to B. And also you can see that they're producing more, so they're definitely going to be better off in terms of profit. Firm B, their quantity doesn't change, but keep in mind that their cost function, their total cost function was affected in a sense because they're not benefiting from that externality anymore. So even though the quantity doesn't change, their total cost is going to go up. And so in the end, their profit is going to be lower. So since we have that one firm is better off and the other firm is worse off, we can say that it's not actually a Pareto improvement because the profit for one of them actually went down. So we could say that profit for firm B goes down because they produce the same quantity of 5 at the same price. And then profit for A, if you calculated it, it would actually go up. And so the point is that it's not a Pareto improvement because no firm should be worse off and firm B is worse off. But notice how it is still a Pareto efficient output. So it seems like it's kind of contradicting, but we could say that's Pareto efficient for society because you were basically maximizing sales. There's no deadweight loss like there would have been before. So it's social efficient or Pareto efficient, but it's not an improvement for the firms. So it essentially depends on whose point of view you're looking at it from. Now they should also actually specify, usually when we talk about efficiency, we're talking about society. Here, when they talked about Pareto improvement, they meant for the firm specifically. So I think if that came up on the exam, I would just ask the teacher to clarify whether they mean for the firm or for the society, because usually it's for the society. But this portion here was specifically for the firms. Now for part 3, we have the government intervening. So basically, instead of having the firms merge, the government is going to, in this case, give a subsidy specifically to firm A because they're the ones that are causing the positive externality. So we want to figure out what the subsidy would be to make it effective and lead to an efficient allocation. So basically to lead to the same quantity that was socially efficient. So generally, if you're talking about a subsidy, you always want to give a subsidy that's equal to the marginal external benefit that the firm is causing. Well, if we're talking about taxes, that would be obviously for negative externalities, then it should be equal to the marginal external cost. It's the same kind of logic though. So we would have to calculate the marginal external benefit specifically at the socially efficient quantity. So 1 second. So the external benefit, that was the part that was the part that was affecting the cost function of B. That was this. So we could say 4x is the external benefit. That B has on A. We want the marginal one, so per unit basically, or per extra unit. So if we derive that, that's going to be 4. So basically every unit that A produces, it causes B's total cost function to go down by 4 euros. And so because marginal external benefit is constant, then your Pigovian subsidy, which is just a subsidy per unit, it's just going to equal 4. So basically the idea is that the government is going to compensate the firm A with 4 euros per unit that they produce. So generally you would have to plug in the socially efficient quantity, but in this case there's no variable. So there's really nothing to plug in. But if you did have to plug something in, we would have to go back and find the socially efficient quantity for X, because X is the quantity of firm A, which is the one that's getting the subsidy. So for the socially efficient, I think we calculated that here. Yeah, we had X equals 12. So we would have to plug in 12 for for the marginal external benefit. But again, here there's nothing to plug in. Either way, it's going to be 4. So basically, that would be another way to lead to the same outcome, rather than having the firms merge. So it's going to be, and it's going to end up being basically almost the same result as before. The difference, though, is that if the government is giving a subsidy, basically the government is obviously spending money to do that. So firm B is still benefiting from the external benefit, but then the government is basically stepping in to compensate firm A for that. So in the end, firm B still benefits, and firm A now also benefits. So the difference is going to be in the profit. So that should be it for this question. Yeah. And now we have the other type of question, which is when you have a single firm that either causes a positive externality or a negative externality to society. So instead of being to like another firm, it's to society. So in this case, we have vaccines. So they're probably even going to tell you, but obviously here we're dealing with a positive externality. So the idea is that you're going to have people who aren't actually purchasing or getting the vaccine, but they're still going to benefit from it. So in this case, you have your external benefit, which is equal to Q. So we're probably going to need a marginal external benefit. So we can just derive that right away, and that's going to give us 10. So first we want to find, we have the demand and supply. Specifically, they're actually giving an inverse demand and supply because they solved for the price. Supply was horizontal. And we want to calculate and draw the competitive equilibrium. So obviously to find the competitive equilibrium, that's just a classic procedure of making supply equal to demand. You just have to make them equal to each other. And remember that you can either take the prices equal to each other, or you can take the quantities equal to each other. But since they've already calculated or solved for the prices, it makes the most sense to set those equal to each other. First supply is 50, and the demand is 100 minus Q. So then we're just going to get a quantity equal to 50. And then as usual, you can just plug it back into either one of the two and see what the price is, but also we just already see that price is always 50. So here it's pretty obvious. So that's this one over here. So we had the external benefit was 500. So that's the amount that basically they're not being compensated for. So the idea is that anytime there's an external benefit or an external cost, so whether it's a positive or negative externality, that's never going to be socially optimal. So it's never going to be Pareto. It's never going to be Pareto efficient. That's regardless of what type of externality you're dealing with. Because the point is that because I believe the point is you should internalize the externality, like we did before, basically with either basically with the merger, although that was a different situation. So anytime there's an external benefit or cost, it's never efficient. And specifically, we can say that because basically they should be compensated for this 500 euros, it's almost as if they should be getting more money than they actually get. So if they could actually get more money, then they would be able to produce more. So the idea is that with a positive externality, you're always producing less than socially optimal if the government or if anyone doesn't intervene in any way. And with negative externalities, you're always producing too much. So we can say that the socially efficient quantity is going to be higher than what we found, which was 50. So this is always the case for positive externalities. So they also wanted to know the social welfare. So by social welfare, they want to know the basically welfare or surplus to anyone. So that includes consumers, producers, and also the rest of society. So we can see here that because the supply function is horizontal, basically the idea is that producers are always willing to sell at 50 euros. And so because they are going to sell at 50 euros, they're not going to get any surplus. So essentially, they're not going to have a profit in this case. While for the consumers, we can see that they're willing to pay these prices, and then what they actually pay is 50. So they're getting a discount. So we have a consumer surplus, but we don't have a producer surplus. So this is all consumer surplus. And then we have the external benefit that we said was 500. So the total welfare is going to be consumer plus producer plus external benefit. The consumer is, as usual, a triangle. This intercept, I think, was 100. Yeah, because it was 100 here. So the height was 100 minus 50. So we take a half times 100 minus 50 times the length of 50. Producer surplus is 0, and external benefit we said was 500. Up with this should be 1250 plus 500, so 1750. Okay, so that should be it for 1. Now we want to find a socially optimal level of vaccines. So basically, if you want to find a socially optimal one, you want to internalize the external benefit. So we have to basically take into account we have to find the marginal social benefit, which is the sum of the marginal private benefit and the marginal external benefit. So we have to take MSB and make that equal to the price. So basically we have that previously for the supply function, we had 100 minus Q. Now we can see that the marginal external benefit was 10. So basically the idea is that if they were internalizing that, they would get an extra 10 euros per unit. So essentially the demand would shift. And it would shift specifically to the right. So see how if you move to the right, your new equilibrium is going to be over here. So that's going to lead to a higher quantity, which is going to be the socially efficient one. So the point is that demand should go up in the sense that the consumers should actually pay 10 euros more if they are being kind of forced to pay for the external benefit. So we just have to add 10 to the previous demand function. So we have to take the previous demand function plus 10 euros. So that was 100 minus Q plus 10. And then, of course, we have to find where it intersects with supply. And the supply function was always 50. And then we solve for the quantity, and so we get 60. And generally, it's always good to check if the graph makes sense, because like, as we said before, like with the positive externality, the socially efficient quantity is always higher than it was before. So if you accidentally drew it, the wrong way, you would realize, like if you drew it like that or something, you'd realize quantity goes down, which just doesn't make sense for a positive externality. So you can always just check by thinking about it like that. So we found our new quantity. So again, it's higher than the previous one. And then they want to know the max amount of money that third parties, so they mean basically the people benefiting from the externality. How much they would be willing to pay to shift to that result. So generally, anytime that they ask you something like how much would people or like a firm be willing to pay to go from like this situation to the next, you really just have to figure out like how much better it is now with respect to before. So if we're talking about the people who are benefiting, we basically want to see the extra benefit that they would get, the extra external benefit that they would get if we shift from 50 to the new quantity of 60. So basically we know that if they didn't pay anything, we would be at the original situation and they would get the external benefit, which would be all of this. So what we care about now is calculating the extra external benefit, so the additional external benefit that you would get by producing this quantity instead. So you want to just look at the difference between the two. So we take the external benefit that we have now minus the external benefit that we have before. And we had our external benefit function, which was, I think, 10Q. So we just have to plug in the two quantities. So 10 times the new quantity of 60, and then 10 times the old quantity of 50. So 600 minus 500, and that's going to be 100. So also just to kind of see the similarity, it's kind of like, I mean, if instead we were talking about firms and whether they're willing to pay something to like to switch from one situation to the other, you're always looking at the difference in the benefit that they get. So with firms, we'd be talking about the difference in profit, but it's the same kind of logic that you just want to see like how much better the situation is now with respect to before. So you're always kind of comparing the two and taking the difference. So that should be it for part 2. And okay, so now we have
something about part 2.
Mm-hmm.
Can I ask something about part 2?
Yeah, go ahead.
Why did this shift the demand instead of the supply?
Well, you could actually look at it either way. Wouldn't change anything really in the end. But graphically, it's more correct to do it this way because the idea is that the firms have an externality specifically on the rest of society, which essentially is the other consumers. So the idea is that basically people should be demanding more than they actually are. It's not actually the supply that should be affected directly. While with cost, it's affecting the supply function. So if you have like a negative externality, basically that's a cost that you should take into account. So generally with negative externalities, you change the supply function. And with positive externalities, you change the demand function. So you want to think about like who basically should be kind of like be held responsible for the externality. And so here you're causing the effect on the society. So society should be basically paying you back for that, if that makes sense. While with a negative externality, you're causing, like you as a firm are causing the externality. So that should affect your supply. It should affect your costs essentially.
Great, thanks.
Okay, perfect. So now we're saying we're dissatisfied with competitive outcome. Competitive outcome is just referring to the original equilibrium with no subsidy or taxes or anything. And now we have a specific subsidy of €5. So the sellers are going to get €5 more for each unit sold. So essentially, we can say that it's also equivalent to saying that it's almost like what I want to say, sorry. The consumers are basically paying them in not literally €5 more because the government is intervening, but it's the same effect. So we want to figure out how that's going to affect everything and if it's going to be Pigovian. So if it's Pigovian, that means that it's going to increase increase the previous quantity to the socially efficient one. And to figure that out, it's actually very easy because it's actually the same thing we had earlier with the other exercise. In order to be Pigovian, you have to have a subsidy equal to the marginal external benefit at the socially efficient quantity. So marginal external benefit we saw was 10. So it's always 10. So then the subsidy should simply be €10. So basically we can see right away that the government is only offering €5 rather than 10. So it's better than nothing. It's going to increase the quantity by a little bit, but it's not going to increase it all the way to 60 because to do that, you would need a higher subsidy. So even without doing any calculations, we could say that right away, that a Pigovian subsidy is equal to the marginal external benefit at the socially efficient quantity, which we can call QEFF. So since this subsidy is too low, it's not going to increase as much as we would like it to. So generally, any subsidy is going to cause quantity to go up, but it's going to be lower than the efficient one, which was 60. And just to clarify with the notation, usually they call this one QF, and this one is usually Q star. So if we wanted to actually check by doing calculations, we could basically figure out how the graph is going to change. So since the subsidy is specifically given to the sellers, that's going to affect the supply function. So I'm just going to copy this. So basically the sellers are essentially able to sell at a price that's €5 lower because then the government is paying the difference. So the supply function is going to move like this. So this is S with the subsidy. And as I was saying before, sometimes, especially when they're like horizontal or vertical, it gets confusing as to whether you should shift it up or down. So just think about like what makes more sense in a sense that the original equilibrium was Q star. The new one now, if you have the subsidy, just want to erase this, it's going to be over here. So you can see the quantity goes up, which makes sense because obviously with a subsidy, you're going to be able to produce and sell more. So if instead you accidentally shifted it up, you would realize that you do the opposite, which just wouldn't make sense with a subsidy because then you'd have a lower quantity. So I always like to double check with that because I think it just helps to make sure you don't make any mistakes. And so, of course, if we were talking about negative externalities, we'd be talking about a tax, and that would shift supply up rather than down. So if we want to find the new quantity with the subsidy, we can call that Q sub. And it's the usual thing. We just have to take the new supply function, which we know went down by 5. So now this is 45. And the original demand, which was 100 minus Q. And then you just get Q equals 55. So it's obviously an improvement because it's higher than 50, although we already knew that. But as we said before, it's going to be lower than quantity efficient, which was equal to 60. So the point is it's not going to be it's not going to be Pareto efficient. It's not going to be optimal for society. And they said determine the consequences of this policy intervention. I'm not sure how much they wanted you to calculate here, but we could also look at how social welfare changes. So basically, because it's better, but it's not optimal, we're going to find that social welfare increases with respect to the original equilibrium. But again, it's not going to be maximized. That's why it's not socially efficient. So when we say that it's socially efficient, that means that you're getting as high of a total welfare as possible. And so in this case, it's just not happening because specifically, we're still going to have a deadweight loss. So if you did want to calculate the new social welfare, we also have to take into account the government expenditure, because when we talk about society as a whole, generally that also includes the government. So we have basically the producer surplus, the consumer surplus, and the external benefit as before. But then we also have the government spending for the subsidy. So basically, we can see if you look at the graph that consumer surplus was previously this triangle. Now consumer surplus is going to become higher because it becomes all of this. So it's a bigger triangle than before. Let me just make that clear. So as usual, we can just do a half times the length times the height. So length is now the new quantity, which we found was 55. And the new height also happens to be 55 because it's the difference between 100 and 45. External benefit, easiest way to calculate that is just with the equation. So we just plug in the quantity into that. So 10 times 55. And government expenditure, that's the money they spent on the subsidy. So they were giving a subsidy of €5 per unit. So that's going to just end up being 5 times the quantity of 55. So if you calculate that, that's going to give you 1787.50. And I think we calculated it before as well. Yeah, we had 1750. So it's definitely better. It's an improvement. But it's not going to be as high as if you had calculated the social efficient one. And that would basically be all of this here. So if you calculated that, that's going to be even higher, which again implies that we're not maximizing the social welfare. So I guess we can quickly calculate that because it just takes a second. So this triangle, the length is 60. And the height is the difference here, which would be the difference between 110 and 50. So also 60. And that's going to be 1800. So yeah, that would be the absolute highest social welfare that you could get. So that would include the external benefit. And if we don't have a subsidy or anything, then obviously there's no government expenditure. And also one more thing that we can do, I don't think they asked us, but we could calculate the deadweight loss. So just to see like which triangle you have to take. For the deadweight loss, you want to find the two equilibriums, like the original one at the competitive equilibrium, which was this one, and then the socially optimal one. And then remember how I said before that basically you want to look at at kind of I guess I don't want to call them the original functions in this case, but at the optimal functions, in a sense that supply function, we only have one of them. But to reach the optimal equilibrium, by optimal I mean like efficient, we were using this demand function. So this is a demand function that takes into account the externality. So the point is you're taking this line, then you're taking this line, and then you're looking at the 2 points, and again, creating a triangle. So the triangle is going to be this over here. That's going to be your dead weight loss. So then, as usual, you could calculate that by doing the usual calculation of area of a triangle. Notice how in this situation, the dead weight loss triangle is actually, to the right of the original equilibrium. So that's why earlier I was saying, like, to kind of think about which curves you're taking, because sometimes it's going to be to the right, sometimes it's going to be to the left. It all depends on like what we're dealing with. So rather than memorizing every situation, you just want to think about like the optimal situation for society, like which curves that would use. And then you take the triangle by using those curves and also those points here. And if we had been dealing with a negative externality, then the triangle would be to the left. But again, you can figure it out the same way.